So let us work example 12.5, children. So let us see what the question is. Right. Now, so he has given us a wire of metal wire of 1 meter length and 26 ohm resistance, right? And he has given us the diameter as 0.3 millimeter. Okay, that's it. So we have to find out the resistivity, right? So what will be the resistivity of the metal at the temperature? So that is the question, right? Now given, what is given to us? Length is given to us, and the resistance is given to us. Then after that he has given us the diameter. Okay, so it's given in millimeter, so we'll convert that into meter. So okay, right, that's it. Then next we'll find out the area. Area is not given to us, so because we need to find the area, right? So that is right. So there you are. So area equal to pi r square, that is not equal to pi d square and d by 2 whole square, or otherwise, so that becomes, I'll employ or substitute those values for diameter, then I'll get so that is it, right? Okay, then right, okay, so there you are, I'm getting that value, right? Okay, so now what else? So I'm multiplying that, right? Okay, when I multiply that, right, I get right, okay, that's it. And what else? So that is what I have written here, the value I get, okay, that is okay, into 10 power minus 2, 10 power minus 6, so that becomes 7.07, okay, approximately, that is 10 power minus 8, so that is meter square. So we got the area, right? Okay, the next, what is the thing that we are finding now, right? So we are going to find out resistance, so resistivity. So we know R equal to rho L by A. So what will be the value of rho? So that is it, and I'll employ all those values that I got here, right, by 1, right? Then next, okay, so when I multiply, okay, here, and how much would that be? Right, good. So I wrote those, I write that value, whatever I got after multiplying, right? Okay, so that is that much, minus 6, so you'll get minus 6, okay, right? So we'll just remove this multiplication from here, and what is that rho value? So you got the rho value as 1.84 into 10 power minus 6 whole meter. So what is the material then? Okay, when you compare the values of when you compare these values, so we find that the value corresponds to manganese. The material is manganese, right? Okay, so there we are, children. So that's the solution for the first one, right? So children, right, let us work example 12.6, right? So that will be a wire of given material, okay, a material whose length is given, the area of cross section, the resistance is given as 4 ohm. And what will be the resistance of another wire? It's another wire, but remember it's same material, right? Length of the second wire is L by 2, and the area of cross section is 2A. So we have two wires, wire 1, wire 2, right? Okay, length of the first wire is given L, area is given A, right? And resistance is given R1 equal to 4 ohm, right? Next one, length of the second wire is given, so that is L by 2, area of cross section is given, that is 2A, resistance is R2, and that we have to calculate. We don't know that, right? Now let us go ahead. So we know that R equal to rho L by A, right? But rho is equal to R times A by L, okay? Similarly for this also I write, but R2 into, so 2A by L, okay, right, done. Now that's L by 2, right, okay. Now that comes out to be L2 by L. So that is so 4 into R2 A by L, right? Okay, so I write that, okay, then that is it. Now both of them, these two equations, they both are representing the same thing. They are the resistivity of the same material, so that will naturally, so therefore R1 into A by L should be equal to 4R2 into A by L, okay, right? Then what happens? Right. So there you are, we are cancelling that, and we get R1 equal to 4R2 or R2 equal to R1 by 4. Right. So we know R1 is 4 ohm is given, right? So we'll divide, I'll get that. So R1 is 4 ohm. Okay, done. That's the thing, right? So we move to the next one. So children, right now we will work the in-text questions of page number 209. Let us quickly answer these, right? So what is the first answer? So for the first question is on what factors does the resistance of a conductor depend? So what is that? So it is resistance of a conductor depends on length of the conductor, area of cross section, material and temperature, right? Then we move to the next part. So what is the next one? So on will current flow more easily through a thick wire or a thin wire of the same material? So when connected to the same source, why? Okay, so current flows more easily through a thick wire because the area of cross section of the wire is more. So we know that the resistance is inversely proportional to the area of cross section, is it not? So as the area of cross section increases, resistance decreases and leads to the current to flow more easily, right? Okay, now we move to the next part, that is now the third question, let the resistance of an electrical component remain constant while the potential difference across the two ends of the component decreases to half if it's form a value, right? Okay, so it's becoming half, the second potential difference, right? Now what change will occur in the current through it? So this is question number 3. So right, question number 3. So we know that by Ohm's law, right? We know that, right? So V is proportional to I at a constant temperature, right? So that implies V by I should be a constant, right? So what is that constant called? That's called the resistance of the material. Okay, right? So that is the resistance of the material. So observe carefully. So we should have V1 by I1. For V1 potential difference, I1 is the current. So that should be equal to V2 by I2. Is it not? Right. Okay. That's it. Now next we have, okay, right, V1 by I1 should be equal to V2 by I2, but V2 is V1 by 2 because we are changing the value of potential difference to half. Okay, so that is I2. Okay, right. The next, therefore, right, I2 should be equal to, right, there they get cancelled, and I2, that is 2I2 should be equal to I1. So that implies I2 should be equal to what is that? I1 by 2. Okay, right. So there we are. So that is the solution, right? Good. Now we are moving to the next one, right? Right. So we go to the next one. Right. So that is the thing, children. Now we'll move to the next part. What is the question? The fourth question, right? Why are coils of electric toasters and electric irons made of an alloy rather than a pure metal? So what is the answer for that? Okay, so let us see. That's right. There is answer 4. So right, answer 4. The first point we'll write alloys don't get oxidized easily. Okay, even at high temperatures. So that is even at higher temperatures. Okay, right, done. Then next, what is the next one? The second point. What is the second point? So we write the second point. The second point is so alloys have higher melting points. Okay, right, done. The third one now. The third one. What is the third point? Okay, right. And alloys have greater resistivity values. Resistivity values compared to pure metals. So for same current, alloys, right? Alloys produce more heat. Okay, done. So this is the reason. Now next one, that is the reason why we use alloys, right? Okay, good. The next one, question number 5. use the data in the 12.2, table 12.2 and answer these. So, okay, when we refer to the table 12.2, we get the answers. Which among iron and mercury is better conductor? So, we know from the table we see that iron's resistivity is less, so that is the better conductor. Now, which material is best conductor? So, the least of the resistivities in those tables is that of silver. So, alright, so the answer would be silver, right? So, this is answer 5. So, answer 5, right? Okay, A, the answer is iron is a better conductor compared to what? Mercury. Okay, right. Then next we have B. So what is that? Silver has the least resistivity among all the metals. So silver is the best conductor. Okay, right. So this is the close, right? Right. Then next we'll be working out the next two things a little later, children. Right. So children, right. Let us work example 12.7 very quickly. So what is given to us? What is given to us? So it's an electric lamp and of resistance 20 ohm, right? 20 ohm, and a conductor of a 4 ohm. They are connected in series, given to a 6 volt battery. And what is he asking us? So he's asking us to calculate the total resistance, right? Okay, in the circuit. The next current through the circuit and the potential difference across electric lamp and conductor. So let us work A first. So as 4 ohm and 20 ohm, these two are connected in series. So it should be R is equal to R1 plus R2. So that implies 4 plus 20. So that becomes 24 ohm. Okay, done. Then second B. Now let us calculate the total current. Now what is the total? Total voltage is 6 volts. Okay, and the total resistance is 24 ohm. Now using Ohm's law, right? Okay. So we have. So to find out I. So that should be equal to V by R. So I is equal to V by R. Right, done. So it becomes 6 by 24 ohm. So result is 1 by 4. So 1 by 4, that becomes 25 ampere. Sorry, 0.25 ampere. So that is the thing. Okay, right. Okay, right. So that's it, children. Now we move to the next part. What is that? What is the potential difference? What is the potential difference across the electric lamp and the conductor? Right. So what is the potential difference? Right. Follow carefully. So right, this is electric lamp, and a conductor. Right. So very quickly we find that we have to find V for both of them. Potential difference. Electric lamp resistance is 20 ohm, and the current flowing is the same current that is flowing in all throughout the circuit, because they are in series. So it should become 0.25 ampere. So result is V is equal to IR. So we have I 0.25 into 20. So that becomes equal to 2.5 into 2. That becomes 5 volt, right? So potential difference across electric lamp is 5 volt. And here R is 4 ohm, and the next I is 0.25 ampere. So V is equal to IR. And so that becomes I is 0.25 ampere times 4, so that becomes 1 volt. So you observe that this 1 volt and 5 volt is equal to 6 volts. So there is something to reason there. Okay, right. That's all, children. Now this we have concluded this example, right?